Hello and welcome to Haybridge Maths Department Year 2 Pure, where we are looking at today Chapter 3, which is Series. And we're going to start off today with arithmetic sequences. If you haven't done so already, could you in a second pause the video and write in your book arithmetic sequences as the title. Okay, let's start off by defining what an arithmetic sequence is. Now, an arithmetic sequence is a sequence where the difference between consecutive terms is the same. It goes up or goes down by the same number, and the best way to show you is to give you an example. So here's an example of an arithmetic sequence. It goes 3, oops, need it on pen, 3, 7, 11, 15 and 19. So you have an arithmetic sequence there because it is going up by 4 each time. If we started off with 3 and 7, but then we went to 13 and then 21 and then 31, you would have something where the difference isn't constant. The second difference is, so if the difference of the differences is, and if you remember back to your GCSE, this was a quadratic sequence because it is going up. The second difference is constant, but that certainly is not an arithmetic sequence. Here's another example of an arithmetic sequence where the first term is negative. It's still going up by 2 this time, so it's going up by the same number, so that is an arithmetic sequence. Here is something that is not an arithmetic sequence, and it goes 3, 6, 12, 24 and 48, and here we are not adding on the same number each time, we're multiplying by the same number, we're multiplying by 2, and therefore it is a geometric sequence, something that we're going to look at a lot more further on in this chapter. Okay, so arithmetic sequences don't have to go up, they can go down. So here's one that goes down, 8, 5, 2, minus 1, minus 4. And as you can see, it's going down by the same number each time. This time is 3, so the common difference is minus 3, but it is still an arithmetic sequence. One more example of not an arithmetic sequence. We start off with 3 and 7 again, but this time we have 10 because this time we added together the first two terms to get the third. The fourth term comes from adding the second and third terms, so we get 17, and then I hope you can see that the next term is 27, and we can carry on here. Let's stick an ellipsis in to say we can carry on, and that is an example of a Fibonacci sequence. Okay, if you could now pause the video, but first of all, let me tell you what to do, which is to write the definition of an arithmetic sequence, write down the examples of an arithmetic sequence, write down the examples of sequences that aren't arithmetic, and if you're feeling very confident, you could write down a couple of examples of your own. So pause the video now. Okay, let's have a look at the labelling conventions for an arithmetic sequence. Right, unsurprisingly, because it's the first letter in the alphabet, we use A for the first term, we use D for the difference, the common difference, and then N because it's traditional for the number of terms. So if you had a sequence, say 5, 8, 11, 14, and 17, then if we looked at that sequence there, then we have A equal to 5, D equal to 3, and N equal to, well, there's 5 terms there, so N is equal to 3. Right, if you haven't done so already, could you copy this down into your notes by pausing the video, writing down the labelling conventions, and then writing down my example. So pause the video now. Okay, that's all very straightforward. Now, and it's quite obvious why we do A, D and N. But then we have a way of labelling each term in the sequence, and we use U for some reason, but I'm not exactly sure why. So we'd say that the first term is U1. U2 are a bunch of geriatrics who complain about third world debt but live as tax exiles. If you don't get that joke, ask your parents. But U2 is also the second term in the sequence. U3 is the third term. U4 is the fourth term. U5, fifth term, etc. A general term somewhere in the sequence would be UK, and then right at the end, the last term in the sequence would be UN. So if we look back at that sequence that we had a minute ago, 5, 8, 11, 14 and 17. There's the one for my 17. Hopefully your writing's neater than mine. Then we can say that A equals 5. So U1 equals 5. U2 is 8. U3 is 11. U4 is 14. And U5, I can just squeeze it in, is 17. Okay, could you pause the video in a second and just write down the bit about the subscripts and that bit there, and write down my example as well. Okay, pause the video now. Thank you. Okay, here's a very, very simple example. Well, I hope it is at least. We've got a sequence, an arithmetic sequence. It's slightly wrong. I've just noticed there's a mistake on it. Let me just change that 13 to 12. Then, if now it is an arithmetic sequence, previously it wasn't. If we just go with that, then the first term, A equals 12. The common difference is 3, so D is 3, and then we can write down that U1 equals 12, U2 equals 15, U3 is 18, U4 is 21, and U5, which isn't written there, is 24. Could you, if you could, just copy down this into your notes, pausing the video, and then once you've done that, could you have a go at this example here? Okay, right, so for this example, we have that A was, of course, equal to 4, D was equal to 6, and then you've got U1 is 4, U2 is 10, U3 is 16, U4 is 22, and U5 is 28. If you got that, give yourself a big tick, and let's move on to another example. Now, okay, so this comes from the textbook, and it's taken directly from there. What we have to do in parts A and B, I hope, are fairly straightforward. Part C is slightly more tricky. There's a few more steps involved, but hopefully you will find it quite straightforward. So in part A, we just have to write down the first 5 terms of a sequence. So we are going to write that U1 is 55 minus 2 times 1, which is going to be 53. U2 is going to be 55 minus 2 times 2, which is 51. U3 is 55 minus 2 times 3, which is 49, and then you should be able to see that U4 will be 47 and U5 will be 45. You could do, if you're feeling you want to make it absolutely clear, you could write that as 53, 51, 49, 47, and 45. Write down the 99th term of this. Well, what we're going to do is we're going to write down that n equals, is part B, n equals 99. So you have u99 equals 55 minus 2 times 99, which is going to be minus 143. Okay, so we're going to have to find the first term in the sequence that is negative. So that's for part C. So what we're looking at is where 55 minus 2n is below 0. So this is how the sequence is generated, and we want it to be less than 0. We want the first number that works for. So what we will get is we will get 55 is less than 2n, so that n is bigger than 55 over 2, which is going to be, well, it's going to be the first number that's going to be bigger than that. Well, if 56 over 2 is 28, so n is 28. But it's not quite the finished bit. We now need to substitute that into our original formula and work out what u28 is equal to. And if we do that, we'll do 55 minus 2 times 28, so that's 55 minus 56, which is minus 1. What I suggest you do now is that you pause this video, and what I would do is I would rewind a little bit, copy down the notes now into your book, pause it again, and then we will move on to an example which I'd like you to do. So could you have a go at this example now? Pause the video, have a go in your notes, and I will go through it as soon as you're ready. Okay, right, let's have a look at this one. This time we've got to work out the first 5 terms again, so we are going to get u1 is 40, ooh, not 48, not sure what happened there, 40 minus 3 times 1, which is 37. u2 is 40 minus 3 times 2, which is 34. u3 is 40 minus 3 times 3, which is 31. u4 is 40 minus 12, which is 28. And then u5 is 40 minus 15, which is 25. Okay, so we want the 199th term this time. So this time we're going to go that so this is part B, u199 is going to be 40 minus 3 times 199, which is 40, take away what, 5, 9, 7, which is going to be minus 5, 5, 7. Okay, and then part C, doing the same thing as we did on my example. You've got 40 minus 3n is less than 0. Then you've got 40 is less than 3n, so n is bigger than 40 over 3. Looking at the first number, which is this happens, so that is going to be, well, 13 and a third, so it's going to be 14, so n is 14. So we've got U14 is 40 minus 3 times 14, which is minus 2. Okay, can you give yourself a big tick if you got those right? If you didn't, could you go back and correct? Now let's have a look at something else. Now what I want to do is look at the nth term. Now I know that you'd have done this all the way back in year 8, but I want to look at it in a particular way so we can generate something algebraically. If we've got here 7, 11, 15, 19, 23, then the first term is 7 and the second term is 7 plus the common difference, which is 4 times 1, so 1 times 4. The third term is 7 plus 2, lots of a common difference, and the fourth term is 3, 7 plus 3, lots of a common difference, and of course the fifth term is 7 plus 4, lots of a common difference. So if we were to carry on this pattern forever, you'd see that the second term we have a 1 here, the third term we have a 2, the fourth term we have a 3. It's always 1 less, fifth term 4. So if we were looking for the last term, then you would have a 7 plus, it wouldn't be n, it'd be n minus 1 times 4. Now we could expand that bracket and simplify a bit, but for now we'll just leave it as it is, because it's useful for how we do this algebraically. Right, could you come up with, using my technique and not anything you used way back in year 8, could you come up with the nth term for this sequence here, please? Okay, if you could pause the video and I will go through it if you are, when you are done. So this time you should get that the nth term is 16 plus 4 lots of n minus 1, and again you could expand it if you wanted to. But why have I done this? Why have we gone about it this way? It's to come up with a general form of an arithmetic sequence that the nth term is given using this formula. So let's show you where that comes from. So if we start with a, the next term is going to be a plus d, a plus 2d, a plus 3d, a plus 4d, and again it's always 1 less than however many terms you've got, so it is going to be that un is going to be a plus n minus 1d. Not so much a proof there, but it does show you where it comes from, and it is slightly different to the way that you'd go about it further previously in your studies. Okay, let's have a look at example 2 now, which wants us to find the nth term of a couple of sequences, one that's increasing and one that is decreasing. So in A, you have A is 6 and the common difference is 14. So the un is going to be equal to 6 plus n minus 1 times 14. So it's going to be 6 plus 14n minus 14, which 6, we can simplify that out, and 6 take away 14 is negative 8, so you end up with 14n minus 8. Right, for part B, you have A equals 101, and this time, because it's decreasing, D equals minus 7. So UN is going to be equal to 101 plus n minus 1 times minus 7. And that is a 7. Okay, now expanding out again, you've got 101. Whoops. Let's start again with that. 101 minus 7n plus 7, which is going to be 108 minus 7n. Okay, could you pause the video, copy this example down into your notes, and then I will let you have a go at something yourself. So have a go when you've paused it at this. Okay, so here you've got a sequence in part A where you have the first term is 5, so A is 5, and D is equal to 2. So now we have UN is 5 plus n minus 1 times by 2, which is going to be 5 plus 2n, take 2. In other words, you've got 3 plus 2n. Right, B, you should have got that A was equal to 24, D was equal to minus 3, so that UN is 24 plus n minus 1 times negative 3, which is going to be, well, you'll get minus 3 and you'll get a plus 3, so you're going to get 27 minus 3n. Give yourself a big tick if you got that this time. If you didn't, as I say, go back and correct it. Right, moving on to the last two examples, one for me, one for you, and it's slightly more complicated than the other examples that we've had today, but let's have a look at those now. Okay, so this comes from example 3 from the textbook, and in this we've got two of the terms that have been given to us, the non-consecutive terms, but we're going to use those to find a general formula for the sequence. So we know that the third term is 5 and the eighth term is 20. Now, I could go back and I could use the general form for UN that we've just been using in the last example, but in the example here themselves, they've actually given it us in this form. So we are going to have to use that there, and it does mean that the question is slightly easier if we do use their form. So what we're going to do is we're going to sub in 3 to it first of all and set it equal to 5, sub in 8 and set it equal to 20, and then we'll have two equations, two unknowns, a pair of linear simultaneous equations, which we'll then solve, and we'll find A and B from that there. So let's start off and say that U3 is 5. So U3 is, using their definition there, 3 times A plus B, so 5 equals 3A plus B. U8 is equal to 20, so we have 20 equals 8A plus B. Right. What we're going to do is we're going to combine those two together, so we've got 20 equals 8A plus B and 5 equals 3A plus B. Subtract one equation from the other and you've got 15 equals 5A, so A equals 3, which implies that B, setting this back into, I don't know, either equation that you want. Let's put it into this equation here. Then you've got 3 times 3, which is 9. 9 from 5, which is minus 4 for the B, equals minus 4. Okay, could you pause the video in a second, get this copied down? You might need to have a look at this bit, pause, and then pause here to make sure that you've got it all down. And then once you've got it all down, can you have a go at the next example? Okay, can you have a go at this example now, please? And if you have had a go at this, then we'll see that U2 equals 22. So that we'll have 22 equals A times 2 plus B. So 22 equals 2A plus B, and you've also got U6 equals 42, so 42 equals 6A plus B. Again, simultaneous equations, of course, linear ones, so you've got 42 equals 6A plus B, 22 equals 2A plus B, subtracting one from the other, and you get 20 equals 4A, A equals 5, which implies from last time that B equals 12. Right, give yourself, as I said, like last time, big tick if you got that right. If you didn't, can you go back and correct now? Once you've done that, what I'd like you to do is it's your turn to have a proper go by yourself, and I'd like you to have a go at exercise 3A. Thank you very much.